Greetings. Today we are going to look into algebra and functions. Starting with algebra, first you need to understand that expressions, they are just numbers and signs like plus, minus, times or divide, and you can have all of them without needing an equal symbol. You can have power indexes like a squared. For the in the expression, you can expand the variable as shown in this example and factorization in this example. On the right, you can see that there is a butterfly method, and this one is what you call cross multiplication. There's also another method called repeated division, but I will cover repeated division in the next video. As a continuation of algebra, we are now looking into coordinates. Coordinates, they are a pair of values that define a location on the Cartesian plane, such as x variable and y variable. Gradient is the steepness of a slope derived from 2 points. There are 3 formulas in which you can look at this example, and then you can also look at the gradient formula involving the use of tangent, mainly because of rise overrun, which is like opposite divide adjacent, and then you get this formula: gradient equals the tangent theta. For line segment, the line segment is a part of straight line with 2 defined endpoints. So you can see in the diagram on the right, the M and N are separated by a single point. And to derive this formula, you're gonna have to derive it from a ratio of 2 distances. For midpoint is a center in between 2 points with equidistant distance from 2 points. You can derive it using the line segment formula. Let's look into solving linear equations. As you can see on the right, this is solving linear equations with 2 variables, and for it to work, you need 2 equations that are distinct from each other with 2 different variables. The manual way is to reduce one variable and solve for that particular variable, and then after you find the value of that variable, you can solve for the other one. And if you look at the working on the right, this is how you solve the linear equations. You have substitution and elimination. However, I will recommend you to perform elimination, since elimination is shorter and simpler to do. You don't need a full page of working just to solve 2 variables. This here is solving linear equations. Instead of having 2 variables, you have 3 variables instead. This one requires 3 distinct equations with 3 different variables, and solving it requires an additional step that's introduced into working. So for the manual part, you need to pick 2 random equations and reduce to 1 variable. Do the same for 2 different ones. You can clearly see this in the working that I made, and you can look into it for substitution and elimination. Then after you reduce to 2 different variables, reduce it to 1 variable, just like in the linear equation working with 2 variables, and solve for that 1 variable. Then you can use the variable that you have and solve for the other 2. And just like earlier, I recommend elimination because you can clearly see in substitution the working is ridiculously long, And for elimination, the working is far shorter. As such, you don't need an entire page of working. You just need like less than half a page of the working. And you can solve the equation using a calculator, but to do that, I will write down in the description as to where you can find how to solve linear equations without needing to write. Now, let's take a look at functions. What are they? Functions are mathematical rules that produces only one output, and there are those that have one-to-one or many-to-one relation, which reflects object onto the image. And if you can see on the right that there is something called a composite function. In composite function, means you combine, you put one equation and make it like the input of the other function. And you need to realize that the range of the inner function must be within the domain of the outer function, because if the range of the inner function is not within the outer function's domain, then composite function will not exist. And just to let you realize that f(g(x) is not equivalent to g(f(x), and this is due to the different arrangement of the function, which will give different results. As for inverse functions are functions that are the reverse of the original one, and this one must be one-to-one function. And if there's a one-to-many function like sub x with a plus minus at the front, then that function is not inverse. The inverse function is a reflection on the graph by the line of y equals x. Now, let's explore variation. Variation describes the relationship between variables. The k is proportionality constant, and as you can see on the right, the variation is described as having like a fish shape. For direct variation, which is y proportional to x, means to say that when x increases, y increases. So to say that if x increases by 2 times, y increases by 2 times. As for inverse, if x increases by 2 times, y decreases by 2 times. And if you look at the graph on the right, for direct variation, it's a straight line through the origin, whereas for inverse variation is a hyperbola if is y against x. For joint variation, when x and y increase and z decreases, f will increase. And for joint variation is simply a result of combining all variables to describe the relation of all independent variables that reflect the dependent variables. And this variation, it can involve power variables, like example, Kepler's third law. Uppercase T squared directly proportional to R cubed. That is an example of variation. Let's look at the lines and gradient, which we're comparing parallel lines and perpendicular lines involving gradient. For parallel lines, the gradient of both lines are the same. The gradient of first line is equivalent to gradient of the second line. To find it, you just need to find the gradient of both lines and compare. If the gradient of both lines are equal, then the lines are said to be parallel to each other. Perpendicular, the line bisects the other line at 90 degrees, and to do this you just need to calculate the gradient of both lines and then find the product of these two gradients. If it is equivalent to -1, then you can tell that the both lines are perpendicular to each other. So you can just take the gradient of both lines and multiply together. Equivalent to -1 means they are perpendicular. There's another way which involves the use of tangent, the trigonometric function, and I think to do that you need to understand how the tangent ratios work, and I've already covered the unit circle in the last video, and I think that's how you get the proof for the perpendicular formula. And I think that's it. This is just the first part of the algebra and functions part, and I'm doing this is because I'm preparing you guys for calculus, which will involve algebra and functions. Thank you.